to go on our Everybody Codes Day 6 quest. I will not use GeForce Experience for this. There it is, a minute out. I did finally get around to, getting these up, and I realized it was at 5 frames a second, so can't exactly get in my time machine and fix that, but I have upped it, so it should be a little bit more pleasurable experience watching this. But I am here. Code is all running. And I am ready to go. I forgot about those long running ones. That's okay. I can get through this without them if it doesn't spin up by then. But here we go. Oh, that's a graph. I don't. Graphs are kind of tricky. We have it. We don't need the trim. Lucky us. The most powerful fruit is RRB at. Well, the path to the most powerful fruit. Okay, that's not where that goes. Let's grab my input so I can see how bad we're dealing with stuff. Not too bad. It's not that, but that's okay. So, RR connects to A, B, C. So it's a directed graph. A connects to D and E, connects to the at symbol. Oh, so what? Are these the leaves? Oh, these are the fruits. RRB at. So same path length relative to the root. So it's the shortest path from the thing. Okay, that's path bounding algorithm. Okay, let's do this. Const graph equals for const line of notes dot split new line const origin equals line dot split on that. Well, origin and raw next const next equals raw next split on the comma. Now I can build up my direct graph. Thanks for coming into the party, Wallaby. Graph origin equals graph origin or empty array. No, let's do it the other way. If not graph origin, graph origin equals the empty array, and then at this point we'll always be pushing to it, not an HTML thing. Graph origin dot push next const next of next. There we go. We should have a graph. Not that. Didn't want to import where the heck that was. Okay, we have ourselves a graph. Now we need to pathfind from RR to the nearest at symbol. Ooh, this is a tough one. It's not a tough one. It's just I don't exactly do this every day. So what I want to put in my paths, just recursion but cheating. Path RR. Yeah, that's it. That's the path. That's all we want to do. So let's return 0 while pass length. So I'm just going to go through all of them, which is not going to be efficient, and then it's all going to break down and fall apart in part 2. But that's future me's problem. Current paths top for const next of graph. Oh, no, it's not current. It's path current equals path dot at path. I really made this cumbersome on myself. This here always a thing. Current or empty an array. You might not be going nowhere. If so, somewhere I need my termination. It's either the next I find it or the one I do find it. I'm gonna say if it's current. So let's do this. If current equals an at symbol, congratulations. Oh, put that back. Almost killed myself. Put it back. Cast found paths. Congratulations, you found a path. Found paths dot push path dot path. Weird. Then we got for this one, we're going to be pushing to all of them. So paths dot push path, and then next. I think that's it. Well, it's path dot path. Boy, I made this weird on myself. That should be good. We're just going to go through them all, and then we're going to console log. Boy, this is, I can see the complexity growing already, and me not doing it good is going to hurt. Okay, so yeah, we got ourselves a bunch of found paths. So we want the shortest one, right? What we're looking for? The path to the singular most powerful fruit. It's the shortest one. Okay. So return found path sort a dot length minus b dot length. Why is my thing not helping me? Oh, because it's doing this. Congratulations, you're an array of strings. You're not an array of strings. You're an array of strings. Is that what you are? Okay, great. So I'm going from smallest to largest, which means this one should be right here. Well, I'll have to join it. Great, which means this one is what this should be. I don't want to forget my at symbol. What? RRNHNN at. Oh no, I've goofed it. Okay, let's look at the found paths. And I guess we're focusing on the hard one, or the one that's failing, but that's brings me no concern, no good feelings here. This is the part where you... There we go, thank you. Half of them don't want to show. Oh, it's because they get long enough, okay. So the shortest, ooh, it's one of the two shortest. Which one? Most powerful fruit. Which one, when they're equal, leads to the most powerful fruit? Okay, what's the one? Oh, unique length. Oh, okay. Const I length equals new object. Const path of found paths. If const length equals path dot length. If not paths by length, then we're gonna do the same thing. Paths by length equals congratulations, you're a new array. Then gonna have paths, but this is a long one to type. Dot push path. We just want to go through all of them that have a length of 1. So we have this paths by length. We have them all. 3, 7. Dagnabbit. RRB at. How can you get there? Why are you not focused? It's this one. I hit my 5 minutes? Okay, I still have time. It's basically for const length and paths by length. Let found equals empty string, or we're not going for found, let's call it unique. We've been overloading that word a lot. If paths by length length equals 1, unique equals paths by length 0. Yeah, we found the unique one. I guess technically you're an array. Congratulations. Return unique, join with this. Now what do I get? I get this one, which if I look at my paths by length, should be the 7 one. I'm good, Wallaby. 7. So RR VVTT at. Yes, and if I unfocus, it'll. Okay, it's still working on the other one. Got a minute left. Okay, this is fine. This is fine. I don't know. Okay, optimizations. For this very specific one, you kind of gotta look at all of them. You can immediately disqualify the ones that you've already seen, so there are improvements to be made there. But I think we're going to be doing something different. Like maybe we're going from one to another one, right? Like without going through the root, or it's the shortest path between two fruits. What's the branch with the most fruits on it? I can do so many variations here. I should probably grab my output and get it ready. Think. How do I want to optimize this now? And this isn't the worst. All this double pathing really hurt my brain though. Do I fix it or do I live with it? I got 15 seconds. I will live with it. This is concerning. We got this going on. Yeah, I'm gonna pretend I didn't see that. Oh, those are my other inputs failing. Boom, okay. Okay, so it becomes eraser. Wee wee woo woo. That's very cool. Let me steal that. This is my second one here. Is the input the same? A path with the branches. Wait, what? Given a tree's impressive size, describe the file path using one of the first letters of each branch. I'm somewhat lost on how this is relevant to the other one. So, confident, the root, more branches to analyze, tree's impressive size, describe the path using one of the first letters of each branch. Okay, so it's the same thing, just change your output a little bit, and we have a lot more input. Let's do that. Solve quest 2. Let's copy it. Use it, which means my notes for this one stays basically the same. Well, actually it's not. I'm getting a completely different thing here, but it's a weird case. R-A-C-E-R at. Okay, I get the logic. I don't have an example to run you off of, so... Which means I don't really have an example at all. Okay, let me just grab my notes. I can at least start there. Expect this to be... Oh. That is obviously eating my computer to death. It's not eraser at, but I'll put something here. And yeah, let me break this up. So, function return path for part 2. Path is an array of string, and this is what I can define. So the first character of each line to the branch, so return path. If you're not a string, you're an array of string. Dot map b 0 dot join empty string. There we go. So let's make sure test mini expect what was the thing called? I forgot it already. return path of part 2 of this input to be racer at. So let me grab this input. It's technically a path, so I will put it in quotes and then split on the comma. There we go. See if that works. Yes, the menu works. Okay, great. So do I just run it and just wrap this on the end? Return path part 2 unique. That seems like what it wants me to do, but I don't have an example to run it on. So do I just hit this and be like, oh, I really hope I got it right? I can analyze the first example and add to it to make sure it's working. Let me do that. I'm going to lose myself a few places for making sure it works. Get me up. Let me go. Where? Jeez, a lot of lines here. Okay, so let me get my unskip this one. So what is the real one? RRB at. So RB at. Yeah, right? That would be correct. RB at, it works. I'm gonna go with it. So it's this thing right here. I have it. No trimming. Got it. Okay. Under attack. Wait, what? You take. Wait, what? Oh, I have to look at things? Where are the bugs? Where are the evil things in my tree? Yeah, wait, did they just really make a big input? Is that all this is? Because they're not... I don't understand. I'm just gonna run it, and if I'm wrong, I'll spend 5 minutes figuring out what the heck this wants from me. So it's a big input. I'm understanding this. Did you end? What happened? Worker exited unexpected. Okay, well, I mean, I was gonna cancel you eventually, but why'd you die on me? I know, just not fast. Q.ts, drop that there. I could be using up too much memory. That's a possibility. Let me in. Let me go down and get my stuff. I just copied it and I didn't copy it. Part 2, love ya, skip ya. There we go. But I need a console log here, so let's get back to the front and de-indent all this. Let's just go to the bottom. Boy, oh boy, that's a lot of branches, a lot of lines. Okay, let me get my terminal in there. Let's see, 24, 6, npx q.ts, run for me. Okay, so while that runs, I'm gonna reread this thing again. Bugs and ants. You make note of them along with other connections. Ah, I did hit it. Yeah. Yeah, okay, I see me. Yeah, this is the most inefficient directed graph I have ever made. I do not disagree. Well, so no, I'm just gonna do it in here. I know this part is particularly offensive. I can drop that. Pass. It's not gonna make it much better. There's a little bit less pain. Are we making the graph or are we failing earlier? Oh, I goofed it. Oh, there it is. Okay. mean, I think the traversal, I mean, they're both bad, but the traversal shouldn't be too bad because it's depth first. I mean, it does breadth a little bit, but... Okay, let's see if I hit that log. Graph made. So I made the graph, it's this traversal that's bad. Okay, well, I can optimize it by checking my next if they hit the thing. It's if found paths is the problem. Let me look at this, see if this is what's killing me. No. Okay, it seems perfectly fine. So, is it? It was. Okay. So it's this here specific traversal of doing all the traverses. I mean, I could go recursive. I kind of was cheating by doing this. Function recur path string array. Still might hit the limit though. I don't know. All these bits, all those bits there. Instead of doing this, just call recur with your next one. I know this is an expensive operation right here, so it can be optimized. Yeah, just do recursion instead. See how that likes it. Recur, I guess I start with the first one of RR. Yes, I could also pass a second argument around. I'd still need to be building up this array or some structure like that. It's fine. If current is an @ symbol, then great. You don't need to look anymore. You can return. Let's simplify this life. Yeah. Do that. Let's see if we get a little bit better. Craft made. Yeah, now we hit the depth limit. Oof. Oof, 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 oof. Why on the @ What the heck is that about? Oh, what am I... Okay, no, that's fine. Maybe I can increase it. It's cheating, but... Oh, ants and bugs. Oh, what am I supposed to do with them? You told me to do something with them. I never actually saw them until now. I guess if ant, if bug, ignore, right? So, if current equals ant or current equals bug, return, right? We just ignore these. Can we just do that? I'm still canceling. Stop that. Stop that. I'm gonna go for it. Nice. Aha. So you could brute force it. You just need to understand. I don't know why I never saw it. So I assume the word bug is... Okay, they're just in here. And it's a it loops back on itself, yeah. Huh. Just didn't see it. Well, that is that solved, folks. I'll go through it a little bit. Break. Refactor. And... Try to explain this a little bit. I do think this will be a beautiful one to visualize. It's gonna be beautiful because like you can just straight up use a cool graphing library and might not be the easiest to visualize in a terminal, but that's okay. Yeah, and since we're not going for the shortest, we're rather going for the unique ones, I guess it would be kind of a custom heuristic to try and target them. It's kind of hard to describe that because can't even fully visualize it in my head. But like basically, it's like, oh, if we've seen 2 of length, like this length of 3 or whatever this length is, and we're looking at this one, so like we see someone at a length of, that's a horrible example. We see someone at a length of 2 about to go to a length of 3, we would deprioritize them compared to someone at a length of 4 that like has more potential for finding uniques. Because this, like, there's a highly chance that you're going to find a non-unique fruit. We don't like that. You still need to iterate the entire freaking graph, though, so... Yeah, okay. My rambling aside, let's get into the actual solution for this. 1 and 2 were identical? Yes, 1 and 2 are identical, so I will focus on the 1, to be honest. Oh. Let's get all the way up here. Hello, hello. Yeah, until that wakes up, I'll go through the 1. So what we're given here, and what I decided to create it as, is a directed graph. So we're given the name of the current node and the name of the nodes that it directs to. So the node RR connects to the nodes A, B, and C. Just like this visualization here. They're doing a tree. It's not necessarily directed in their case. It's just a path, but that's the way I saw it in my mind, and that's the way I built it in my data structure. Then, yeah, we do this for all of them, and then we have a special character that isn't technically a node. It's a destination or an entity or an item or anything. And when that's the @ symbol, that's the symbol they decided to use for fruit or the goals we're searching for. And then they just list all these out, which if you were to build it in a graph and draw lines between, like the R's, the A, B, C, and then draw from A to D and E, then draw from D and E over to their fruits, it comes out like this. And our goal here was to find the one with the uniquest path length, or unique path length. There'll always be one that is unique. So this one has a path length of RRAD fruit, so 1, 2, 3, 4. And then RRAE fruit, path length of 4. As soon as that happens, both of these get disqualified. They cannot be considered. Then 4, and then 3, which meant 3 was the only possible valid one at this point, but there was still a risk we could find another 3. So we found a 4, we found a 4. Then 3 was the only one that had a... Like this particular path, RRBA, was the only path with its length. 2 is just do it again, but change your output slightly. I'm not sure. I guess if you were destroying your data as you were traversing through it or not preserving all of it, this would have been more of a challenge. And then this part here was when you see bugs and ants, you're supposed to ignore them, which is interesting. I could see this honestly as like a part 2, and then like in part 3 you do something with the bugs or ants, but that's it. Okay, I want to look at this raw next. I think this is complaining about. Okay, I'm not going to do that. So that is the problem. And here's how I actually solved it. You saw it, but explaining it. First we go through each line that we split out. Is my focus not working? Well, part. Hold on, my brain. Part 1 notes. Okay, it's gonna be a second, I guess, for that. Really gonna optimize that. But first, what we do is we go through and we grab every line. So that's splitting on the new lines. So first line is this, second line is this. You get the gist. We split on the colon, which gives us 2 strings RR and A, B, C. We do a little destructuring here. We then take the A, B, C. We split it into commas, so we get 3 strings A, B, and then C. And then we do our graph building. So what this graph is, this directed graph structure I've made, is the keys are origin nodes. The values are arrays of destination nodes. So if you are like, hey graph, I'm at A, where can I go from A? It'll tell you these 3 other places. But first we initialize it of like, hey, if we've never seen this node before, then let's add, like, let's set up an array. You technically don't need to do this because you'll see every origin once and exactly once as an origin. But I do this as safety to make sure that it's always set up. I specifically mean we don't need the check. We still have to set it up as an empty array. Then we go through each of them, the ones that are next, and we push them all here. Honestly, could have just done that, but this is the way I've ended up doing it. And then for the pathfinding, I decided to go with a iterative loop, which is essentially the identical version of the recursion, but just doing it in the heap instead of in the stack, because these would be my arguments to my function calls, as you saw in my other one. Over here, I basically moved whatever that was in the thing, in that stack of arguments to be processed, into the parameters for the next function. So just a simple way of doing that. Obviously neither worked because there were bugs and ants creating an infinite loop, but I didn't see that. Yeah, so we have basically the paths remaining or that haven't been processed finished. We pop one off, so now we have a current path. We get where we're currently at on it, which is at the end of this. So in this case, it's RR. If we're at a fruit, then we're like, congratulations, we found a path to a fruit. We're going to keep those for later. Otherwise, we'll look through all the ones that we could go to. We optionally chain it or nullify, whatever the heck that operator is called, to an empty string in case, like, there's this one goes to Z and then we never found Z, so like Z would go to nothing. We're handling that case. Then we push the new path, which is the current path plus where you're going next. This could be optimized slightly by moving this check of, hey, did you make it, into here. This would reduce the memory and the recursive calls by a lot. Well, it would reduce it by the number of fruits. Yeah, the next bit, yeah, I did a lot of 3 operations effectively here. Finding the paths, then grouping them up by similar lengths. Exact same similarity to the group, the graph of like, hey, I've never seen you before. Gotta create an empty array so I can push me and my future friends in there. This honestly could have been done as part of this found paths push. I just didn't see it. I thought we were going for something else. And then this unique could also be done in an optimal way. What we're doing here is we're going through each of the keys in this object. We're using that key to get the array, which was defined here, and pushed to here. And we're saying, hey, is there only one of you there? Because if so, we found it. You are the chosen one. Congratulations. And then we should break here, but we're not. So we found the chosen one, but we're still going to annoy every other path because we're like that. And then we return the chosen one. All of this, and you'll see when I refactor this a bit, can be consolidated into basically this check, or this line here, where you only count up the paths by length. The moment you already, like this part here can be a little more logical of, hey, this is the second one. So it starts off with nothing. Let me start from the beginning. You haven't seen nothing. Then I find a path of length 4. Okay, path of length 4, you are in the running. You could be the chosen one. And then I found another path of length 4. And it's like, I'm really sorry, path of length 4, the first one I found, you are not the chosen one. There's someone who looks just like you. You are not special. So from that point forward, we flip a flag of like, hey, these are not special. We don't even need to store them in memory. If you see another path of length 4, which you will right here, we've already determined that they're not cool or the chosen one. So all we need to store is the first path of every length in memory. And then as soon as you find another one, just increment a tiny little counter. You can even clean out that memory by getting rid of it. But then we'll get to 3. You'll be like, you could be the chosen one. I'm going to remember who you are. RRB fruit. And then we don't find anyone. And we're like, okay, who is my chosen one? It is RRB fruit. But that's an optimization that I have not done yet. Yeah, and then this part 2 is just change your format a little bit. Considering... Come on, Walden. So I was saying, considering I did just describe the entire process, I will be actually optimizing it and all that without a delay. But let me get these into their positions. Part 2, which I did have an example there. I'll keep this mini test here just for good luck. I did write it. This one, this is my part 2. Let me grab that answer and scroll. I really gotta get these inputs out of these test files, but I'll get there eventually. Boop, there we go. Now part 3. I don't have an example. If I were to write an example, it would have bugs and ants in it, but I don't. This is the part where I'm going to bring over my answer. So yeah, this is a change I made, so I'm gonna go ahead and bring it over, despite it having no functional impact. Yeah, I did make it to the change part 2 code, so it's gonna live here, comments and all, and then I'll refactor it after all of that. Good. Yeah, looks good enough. Recur. Yeah, all that happens. What was our part 3? Right here. And we scroll. Okay, now let's make sure all these are functional. I'll commit. And then I will refactor. That told me nothing. I mean, it told me it passed, but it covered my entire screen. Theoretically, I can just hit that and I'll hit them all. What is up with 05? What is going on? Oh, am I not doing a run? Okay, it looked like I was in watch mode. There I was. Okay, found it. 06 quests, they're all passing, including my weird friend there. You look really weird where you're at. But that's a fine enough position. Which means I can ditch this one and commit. Add solution. Add initial. 06 a solution. There we go. And I'm gonna take a break, and then I will do the refactoring. We'll see you after the break. Hello. Today I'm going to refactor my Everybody Codes Quest 6 solution. As a reminder, it's the tree-based one where we're meant to find the shortest, no, not the shortest, the unique path length to a fruit, do the exact same thing, change the output a little bit, and ignore all bugs and ants. So, I've already done this. Here's the code of the actual what I have. Boy, there's a lot in here. It's going to be real nice when I shove these into files. Let me get tests going. Smush all of these. There we go. Day 6, let's hit it. 15 milliseconds. I love it. Okay, so let's identify what we got going on here. So we have solve quest 2, and then part 2 format a little differently, which is technically 2 and 4. So I bet they are the same. Okay, one of them does it with recursion, the other does it with just creating the thing in memory. I have no preference for either, really. I know recursion is scary to some people, so I'll probably just dip that one out. Is the difference literally just how we return it and the ignoring of bugs and ants? So if I take the ignoring of bugs and ants and I add it to this one, so if we find a bug or we find an ant, we ignore it. Then theoretically, we can just use this function in the place of this one. Oops. Ah, dang it, there's a multi-line string in there, or there's a comment in there, multi-line comment rather, so that didn't work. This is what we have get for, right? It's the worst that could happen. Okay, let's just add a boolean. Shorten path. That's what we're doing, right? Shorten branch names. Boolean. There we go. So it's either shorten branch names or this. And if we're shortening the branch names, then we're just returning this. Nope, I missed it. Otherwise, we're returning this, I believe, which, let's just endline it. There we go. Oh, that was meant to be delete. Let's call this solve quest. We have to pass it our boolean. So for this one, it's false. For this one, also false. Oh yeah, I guess I just deleted that one, so there's no more test we can write for it. True, not true one, true. Inside. Yep, let's drop both of these. Okay, that should be it. Let's see if we broke anything. Still works like a charm. Okay, so we've reduced it to a single function. Now we get to optimize this where possible. So let's start with, I suppose, the generation of my directed graph. Yeah, I mean, it's not the worst. We're going through each of these origin and destination list. We're splitting it, getting all of the next ones. Destinations. There we go, that can help a little bit. If it doesn't exist, we create an array, then we push each of them. This can be done with the old spread operator. Drop that. And then, yeah, I'm perfectly fine with this, personally. Yeah, so we generate the directed graph, found paths and paths. So we pop a path. Okay, so we're doing this when we get it. We can do this when we're adding it. So I'm going to move this to here. Basically, same logic here, but instead of current, it's going to be next. So if you are next looking at an ant, the blah 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 blah, I think this is the only one where we'll need to make a slight change to add next in, at least till we refactor that. Because now we can drop that, it all still works as expected. We just do it at the beginning, so we don't even add this to the array and let us do iterations on it, let it sit there and eat up memory. We're just like, you're good, you're bad, boom. First time we notice you, we'll handle you appropriately. Now, paths by length. Okay, yeah, our goal here is to find the unique length. So I believe I described this earlier, but basically we're going to say as soon as we find a one, like, hey, you have the length 4, congratulations, you are the chosen one. And then we're going to find someone else with a half length of 4 and be like, actually, you were never the chosen one. Much apologies. Let's ignore you forever. And then just keep going. So we keep track of the first one we find of that length and whether they're still possibly unique. So I think this is a nice dictionary. We'll call this results, just arbitrary. Now let's go ahead and define it. It's a record of number, and the value is combining the path and is unique. Boolean. Love it. Okay, so we do this, and this is where we basically replace found paths with this. And then, yeah, we'll keep track of all of them. I guess we might as well go for, that's one iteration or one improvement at a time. So the path is a string. It's basically whatever our result is. So I just need to make a tiny path to string, or what do we call this? Path to string. Sure, it's a good name. Path string array. That one has to persist, of course, and then we're just going to take that one liner and move it up here. Boop. I'm just realizing I could just keep it in memory. Yeah, just keep it in memory. So we have our results. Path is there. Unique is there. Okay, so cos found length equals path dot length if results, or if found in results. Then I'm very sorry to say results. Then it'll be found length dot is unique is false. My condolences. Else results found length equals, you're the first one of your kind. So the path is that line down there, and then is unique is a true. So let's grab that, put it here. Love it. Okay, now that we do that, this is what we look for. So found paths no longer has a use. Path by lengths no longer has a use. This unique no longer really has a use. But we will find it by saying const unique equals, we're just going to search through all the values for the one that is unique true. That find, I think I have is, okay, fine, don't destructure of types. So we found it, and then once we find it, we want the path, so it's dot path. Now types want to work. Great. Love it, love it, love it. Okay, let's see if that still works. Boom, like a charm. What did I do? What's going on? Oh, I accidentally put a curly. My bad. Okay, so this is good. 2 more optimizations really left, I believe. One is that we have this weird path. We have this object, but we've only ever actually tracked one thing. So this can be turned in straight to an array. And then we're tracking is unique on each one of them, which is acceptable, but then that requires to search all of them and look through all the non-uniques for the unique one. So kind of like the unique number or something can be stored out here. Let's go for the one with most impact, which is that. Length equals number max safe integer. It's basically whenever we do this, because this is when we find our unique. Length equals found length. There we go. And now we can just say results unique length dot path. No longer need to do a search. Is that alright? Nope, it's wrong. Interesting. Oh, this is like the latest one, not... Okay. Interesting. What we could do is keep two different things, one containing the uniques and one containing the non-uniques. The removal, though, is going to be computationally expensive. So as we unfind them uniques, we can remove them from this list. So const unique lengths equals new set. I'll make it a little bit more efficient. Lengths dot add found length, which brings this one up. Unique lengths dot remove or delete found length. There we go. So we can take up a little bit more memory, but we can pull it from this, which will only have a length of 1 at that point, and that'll be doable. No, undefined path. So I add it when I find it, I delete it when I realize you're not there. Interesting. What is my unique lengths? I think it must be empty at this point for it to fail like that. This isn't doing what I think it is. It needs to be keys, right? Because technically a set teaches keys, no? Okay, how do I just get the things out of you? Give me your numbers. Almost a bug on that one. There we go. So can you just give me... You're a set. You got stuff in you. I make it a size of 1. Yeah, you have an item in you. Okay, fine. What magical method do I need to use on you? Okay, so it's unique lengths dot values. I'm just gonna give me an iterator. Okay, if I spread that, there we go. So I can get the thing. Could I just call next on you? Would you be cool for that? Yeah, I was gonna call next on you. Don't worry about it. And then we'll do dot value. Spell the word value correctly, and there. We're gonna pretend like that's what I meant to do in the first place. Boom. Easy. This does fail if there's more than one, or not, basically any length not 1. But that should not be possible due to how it is. Okay, I'm liking this. Let's simplify this down to just RR. So basically it removes the double path from everything. Woo, we love it. Still works like a charm. Okay. So I'm liking it. It got a little hairy here, though. It's a lot of ifing and elsing and ifing and elsing. I don't like it. So here what we do is we are like, hey, if we find bugs or ants in the graph, let's just ignore them. We could remove them up here. It's probably the better way, actually. So I could do it in here, or I could do it like an afterthought. It will make it less pure, but I think we're fine. Dot filter dest not equal ant, or dest not equal bug. Yeah, we're just doing 2. It's not that many. What's wrong? Oh, and not or. Whoops. If origin. Whoa. Okay, let's just make this a thing. Cost ignored nodes equals new set. Yeah, let's not make it a set. It's gonna be hard to do my array methods. ant and bug. There we go. So it's just gonna be this dot includes dest. So make sure it doesn't. And if origin includes, no, wrong way around. If this includes origin, continue. We don't want to look at you. Ah. What? No, not that. Continue. There we go. Whoops. What the heck, Copilot? I don't want to hear from you. Ah. There we go. I like that a lot better. So now, we don't have bugs or ants. They're just gone. There we go. Never see a bug or an ant in your life. Okay. I guess we'll have to do, it'll be good to do a conditional here. Basically, if you don't have any left, we don't want to see you anymore. So let's, kind of split these three up. Love it. Okay, so that made that a little easier. Let's flip this around. So if you're not an @ symbol, then you're just continuing with your everyday life, which can drop this else implicitly here. To fruit, length to fruit, or fruit. There we go. Pass by length. That's what these are. Unique lengths. Yeah, I'll keep that going around. Paths. This is good. I mean, it's an if and an else. We add it and set it, or we don't and don't. I see no reason to really try and make this better. It's two different pieces of logic. Okay, that makes it a little better. Map join. It's the mapping part that's changing. And whatever we do, it's always the same. Dot join on the empty string. There we go, we narrowed. Oops, that parenthesis goes over here. There we go. Nope. I broke it. If it's not equal a thing, then continue. There we go. Okay, nice. Nice. We only use current once, so let's just inline that. Do we need that? We didn't. Great. Use path a few times. Let's keep that going. Yeah, we are popping it and then immediately possibly re-adding it. We could do some cheeky thing where like, oh, it's the first one, then modify in memory. I'm not going for that level of optimization. Because it might not have a destination. That's good. Path next. Let's rename it. There we go. Be consistent. Paths by lengths. Unique lengths. So once I have unique lengths, do I need this whole bit here? I don't think so. The presence is telling me if it's unique or not. Let's see how that works. That's right. Which means this don't need to be an object. This could just be the one you found. Let's drop that. Nope. It's because I'm accessing other things. I didn't update all my code. There we go. So we have our paths by length. First path by length. Makes sense in my head, but I can see how those words don't really represent what I'm trying to say. Yeah, I think this is good. Okay, I'm trying to see if I can squash these two into one. So we're still keeping track of all the first, despite we see, like, we're keeping this memory around. It's like, okay, we already know that, like, you're a length of 4, you suck. Let's ignore you. If we make another one, I think memory-wise, it'll be the same, like, keys, but we won't be storing the extra value. So let's go with this. Const new set, and we learn to spell the word duplicate. Duplicate lens. There we go. So if it's not there, then duplicate lens add distance to fruit, and we should be able to. Well, hold on. If duplicate length has duplicate length distance to fruit. So if I've seen you before, that's literally impossible. If I haven't seen you before, then do all that. Then I add you. Okay, so I think we're doing good here. We need to clean this thing up. Let's make sure this is doing good. Okay. We want to clean this thing up. So it's like, okay, you're unique. Congratulations. You are not unique. Let's get rid of you from here. Which I think is... There we go. There we go. Clean that memory out. Nope. So it's unique. We add it here. Okay, this... I've written this a little wrongly here. Okay, so we have a thing. Before, it was if we've seen it before. So if we've seen it before, then congratulations. So if unique lens has this, there we go. So if unique lens has this, then we have seen you before. And then I don't think we need an else. I think we need an else if. Well, actually that might be enough. Boom, there we go. And I'm going to jump through this with a debugger to show how this works. Because I can see it all in my head, but that's in my head, not on the screen. So we'll go through the part 1, which, as a reminder, is this visualization. So we're going to see a 4, and then another 4. And when we see this second 4, we're going to see a lot of memory get cleaned up. So, let's see what we got going on here. I guess this is all my blocks, yeah. So we have 1 unique length. We've seen 3? I could be off by wanting all of these. Graph. So where's my things? First paths by length. Here we go. Duplicate length. Okay, these 3 are the ones that I care about so much that I'm just gonna. Where's the thing? Add to watch. There we go. There we go. And I really should have put this up here because that's what we want to monitor. So let's stop that. Redebug. And smush all our globals. We just care about what we care about. Okay, so we have found a distance to a fruit. It is this. We also want to know what our cool path is. To watch and our destination, just so we can see the entire freaking path. Yeah, RRCH. RRCH. We found this route on the right. Yeah, so all of our distance to fruits are technically off by 1. That hurts my brain because it's legal and it's lying. Let's fix it. Has 0 impact on the code, but it looks nicer following the example. Put the breakpoint on the next one because we don't need to stop there. I want to see. There we go. Can we order these? Yes, please. Yeah, our global, our path, our destination. But this is the right order. Okay, so we have a 4. We've never seen a 4 before. So we're going to say, you're a unique fella. And then we're going to add you to the object. Which just says, hey, this is the first 4 we've ever seen. they're pretty unique. And then we're going to skip on down and we're going to find another 4. And we're going to be like, well, we've already seen you before. So turns out you're not that unique. Get out of my unique set. Go into the duplicate set. And since you're not unique and we don't love you, you're not special, we don't even need to remember your name. So boom, we completely forget who you are. We still keep track that you're a duplicate, like you existed, but only we know that you existed. And then I think we're looking at the 3, so RRB at. So this is actually the good one. We're going to be like, yay, we've never seen you before. And then what's this for? So this is the trick. I'm not fully optimizing it. This is kind of lucky that it's working here. So what we need to do is like, hey, if we've seen you already, then let's just ignore you. But if that has, I need that up here. Then yeah, we don't actually want to ever see you again. There we go. Hit it once more. Okay, yeah, so it's the first time we've seen you. First time we're seeing you again. Looking at another 4. First time we've seen you. This is the good one. Congratulations. But then we're seeing another 3, another 4. So you already seen you. We don't want to look at your face again. There we go. Keep not wanting to look at their face again. And then eventually we are out of here. And technically, we can just go object values on this, because that is all that matters. Nice, so I think we're able to eliminate even one more thing, since we don't need any of that for its keyness. Watch it still work. Then we probably don't need unique lengths at all. We can go back to just using the actual object for it. So let's drop it, and we'll swap this with thing and thing again. So thing in first paths by lengths. If that's true, then we have the deletion going. Otherwise, we're adding it just like that. Boom. It's not going to get any better, I don't believe. We're keeping track of the bad ones' keys only, and then we're keeping track of the good ones' values only. Could go even further and be like, okay, congratulations, you're now undefinable. That would break this. I mean, it would be object values filter, values are not defined. But I like this better. There is 2 things to manage. Oh no. But I like this better. Okay, so we have the building of the graph. It's up there. It's great. And then we have the traversal of the graph, finding the unique length. It's there. It's great. It's working. It's done. Okay, let's call that. Optimize 06 solution. And that is the refactoring of Everybody Codes Quest 6 solution. Pleasure as always.